Welcome back, class. Today we're looking at section 8.3, the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You use the quadratic formula when you can't factor, when you can't use the square roots method, or you can't complete the square. So the quadratic formula is your last resort. So one way I like to remember the formula is by singing it to the Pop Goes the Weasel beat. And it goes like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, just to remind you, I can't sing for the life of me, but I went ahead and did it anyways so that you remember what the formula is. Now let's look at a problem. Okay, so we have 2x squared plus 3x minus 5 equals 0. What I usually like to do with any quadratic equation is check to see if it's factorable. If it's not factorable, then you use the quadratic formula. Since this lesson is titled Using the Quadratic Formula, I'll go ahead and use the quadratic formula for the purpose of this lesson. Now, the quadratic formula is your last resort. So if all the other methods fail, this is the one to go to. So the first step is to label A, B, and C. A is 2, B is 3, C is negative 5. Write out the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative 3, because that's what b is, plus or minus the square root of b squared, so 3 squared, minus 4, a is 2, c is negative 5, all over 2a, which is 2. Let's continue. X equals negative 3 plus or minus the square root of 3 squared is 9, negative 4 times 2 is negative 8, and negative 8 times negative 5 is positive 40, all over 4. What's neat about the quadratic formula is it works every single time. But you have to make sure that the equation is in trinomial form and is equal to 0. Let's keep going. So negative 3 plus or minus the square root of 9 plus 40 is 49, all over 4. X equals negative 3 plus or minus the square root of 49 is 7, all over 4. Now we need to split this up. So we have x equals negative 3 plus 7 over 4. And we also have x equals negative 3 minus 7 over 4. Negative 3 plus 7 is 4 over 4. And 4 over 4 is 1. X equals 1. In our second solution, we have x equals negative 3 minus 7 is negative 10 over 4. Reduced by 2, negative 10 divided by 2 is negative 5, and 4 divided by 2 is 2. And these are our solutions. Now let me show you how to check your work. So to check your work, you're going to take your solutions and just plug them into your equation. Remember, you want to plug it into the original. Let's go ahead and check one first. We have 2x squared plus 3x minus 5 equals 0. Take the 1 and plug it in. So now we have 2 times 1 squared is 1, plus 3 times 1 is 3, minus 5 equals 0. 2 times 1 is 2, plus 3, minus 5 equals 0. 2 plus 3 is 5, minus 5 equals 0. And 5 minus 5 is 0. So 0 equals 0, which means that this checks. Therefore, x equals 1 is a solution. Now let's plug in negative 5 halves. When x equals negative 5 halves, we have 2x squared plus 3x minus 5 equals 0. So that's 2 times negative 5 halves squared plus 3 times negative 5 halves minus 5 equals 0. Negative 5 halves squared is 25 over 4. And 3 times negative 5 halves is negative 15 halves. Minus 5 equals 0. 2 times 25 fourths, that is 50 over 4. Minus 15 halves minus 5 equals 0. So class, I'll go ahead and reduce 50 over 4 so that we have a denominator of 2. 50 over 4 is 25 halves minus 15 halves minus 5 equals 0. Now we have 25 halves minus 15 halves, which is 10 over 2 minus 5, and it's supposed to equal 0. So 10 over 2 is 5. 5 minus 5 equals 0. And 5 minus 5 is 0. So 0 equals 0, which means that negative 5 halves is a solution.